complete the picture into what went wrong. Why is this important? Because figuring out exactly why an accident occurred is a necessary step to preventing similar accidents in the future. In this program, we'll discuss when to investigate, the accident scene, interviewing witnesses, reviewing records, analyzing information, and communicating recommendations. When an accident occurs, it may seem that the reasons are obvious, but the reality is the cause of an accident is almost always more complicated than it first appears. In fact, there is usually more than one cause. Some experts say that when a serious accident occurs, there are often 10 or more contributing factors. To get at the root cause or causes, it's important to sort through all the relevant information in a methodical, professional way. Because it's only by tracing back to the original source problem that permanent safety solutions can be implemented so that similar accidents don't occur in the future. The purpose of an accident investigation is not to assign blame, but to figure out where hazardous conditions exist so that they can be eliminated. Because the goal is prevention, accidents are not the only time an investigation should take place. Incidents are near misses, where someone could have got hurt, but fortunately didn't. Just because no one was hurt, however, doesn't mean unacceptable hazards aren't present. In fact, a near miss is a warning that if safety improvements aren't made, employees are at risk for injury in the future. For this reason, incidents should be taken as seriously as accidents and should also be investigated to discover where safety improvements must be made. Any effective safety program has to emphasize good, proactive communication between employee and supervisor, because the accident or near miss that goes unreported sets up that work environment for a more serious mishap down the road. After an accident occurs, there are two top priorities: making sure anyone who's injured or ill receives prompt medical attention, and ensuring that no one else is in any immediate danger of being injured. After this, as soon as possible, an accident investigation should take place so that evidence that's vulnerable to being lost can be preserved and studied for clues to the cause of the accident. The evidence accumulated in an accident investigation can be divided into three categories: physical evidence at the scene of the accident, interviews with the victim and witnesses, and records and files. Where should an investigation begin? The type of evidence that's most vulnerable to being compromised or lost if not quickly gathered is the physical evidence at the scene of the accident. Therefore, this should be your first priority. The investigation process should never interfere with the medical needs of an accident victim. But once medical treatment has begun and the location itself no longer poses a danger, secure the accident scene. Barricade tape, rope, or warning signs can be used to keep others out of the restricted area. Why is it important to do this as soon as possible? This early in the investigation, it's impossible to know for sure which evidence will provide useful information. And once on-site evidence is disturbed, the clues it might have provided to the cause of the accident could be lost forever. To aid in the prompt investigation of an accident scene, it's a good idea to have an investigation toolkit prepared and ready to go so that no time is wasted gathering the necessary materials. In this toolkit, typical items can include pen and notebook, camera, tape recorder and cassettes, a measuring tape, barricade tape, plastic vials with caps, graph paper, accident investigation forms and telephone numbers, and PPE. At an accident scene, an investigator should look for several types of evidence, including physical evidence, position evidence, and environmental conditions. Physical evidence can be many things, such as equipment, machine guards, tools, chemicals, PPE, and pieces of debris. Position evidence is often transient, but answers the critical question, where were people and things located at the time of the accident? Environmental conditions takes in such things as slippery floors, lighting, noise, dust, vapors, and weather conditions. Taking notes of your observations, along with making photographs and sketches, will help you fully document the scene. Remember, this is not the stage to draw final conclusions. You want to collect as much potentially important evidence as possible to ensure that nothing gets overlooked. If possible, take photographs before anything is moved. Besides providing a visual record of your observations, the ability to study photographs later may reveal information that was overlooked during your initial review of the site. Begin by taking wider shots of the general area. This can help preserve the physical relationship of objects to one another. Then move in to get close-ups of all equipment, materials, or other items involved in the accident, recording important details from several different angles. The rule of thumb is, if in doubt about whether to photograph something, go ahead and take the picture. It's better to have a photograph of something you don't need than no photograph of something you do. If an object's size is important, before taking its photograph, place a ruler in the shot to provide a scale reference. Sketches can also be used to preserve important details and are useful for recording measurements, spatial relationships, and such transient details as the location of a victim. Because it's composed of equally spaced lines, using graph paper can make it easier to draw to scale. The most helpful sketch is usually a basic floor plan that looks down on the accident from above. What should be included in the sketch? Again, the rule of thumb is, show anything that may be of value. To help orient the viewer, be sure to include some easily identifiable reference points, such as doorways, windows, or permanently mounted equipment. While investigating the accident scene, another important task that should be performed is to start identifying witnesses for the next stage of the investigation process. After physical evidence at the accident scene, the second most fragile type of evidence is information gathered from the people involved in the accident. A witness's ability to recall details can fade quickly, and as time goes on, their account of events may be altered by discussing what happened with others or rethinking what occurred. For these reasons, if possible, try to keep witnesses from conferring with each other before the investigation and conduct personal interviews as soon as possible. If you're a supervisor, choose a location other than your office for the interviews, a place that's neutral, comfortable, and private. Conduct interviews one individual at a time and begin by putting the person at ease. Explain to them that the only goal of the investigation is to prevent a recurrence of the accident, not to assign blame or punish anyone. If you take notes, be unobtrusive so as not to distract the witness. You may want to tape record the interview, but do so only with the consent of the witness. And weigh the value of the recording against the fact that some people may find the idea of being recorded especially intimidating. During the interview, draw out detailed information by asking open-ended questions that can't be answered with a simple yes or no. Many of the specific questions you'll ask will naturally vary from one accident to another, but in general, your goal is to elicit the employee's version of what happened exactly as they saw or experienced it. Ask questions in a friendly, constructive manner. Then listen. As much as possible, let the witness talk without interrupting or interjecting your own thoughts or requests for clarification. Conducting part or all of the interview at the scene of the accident is another option. For some witnesses, this may help them explain more accurately the location of each person involved and how events unfolded. But be aware that this setting can also be more distracting than a quiet office. When deciding whether an interview on location would be effective, things to consider include how much privacy the setting would provide, the nature of the accident, and the emotional state of the witness. During an interview, it's a good idea to ask the witness what they think could be done to prevent similar accidents. Not only does this re-emphasize the purpose of the investigation, but the witness may have ideas that no one else has thought of. After the witness has provided all the information they can, summarize their account of events back to them so that they have a chance to verify that the information is accurate. Always end the interview on a positive note, thanking the witness for their help and reaffirming the goal of eliminating accidents in the future. Finally, the third source of information during an accident investigation is existing records. Though often overlooked, they can be a source of valuable background information. Technical data sheets, maintenance records, past accident analysis reports, employee records, training records, standard operating procedures, safety data sheets. job safety analyses, company policies, health and safety committee meetings. Depending on the type of accident and the circumstances surrounding it, any of these may provide relevant information that should be studied for clues about the causes of the accident. Since these sources are already collected and filed, pulling this material for review can and should wait until the accident scene has been examined and the witness interviews are complete. Once you've conducted the interviews and collected the evidence, the next step is to make sense of it all. One of the biggest mistakes investigators make is to reach a conclusion about what caused an accident too early in the process. They identify the surface cause, but close the investigation before they've discovered the root cause. What's the difference between the two? The surface cause is usually the source of the immediate danger. For example, while walking through the plant, an employee has slipped in a puddle of water and fallen. Obviously, the immediate danger is the water on the floor and the fact that it wasn't mopped up. But by continuing to ask why, the investigator discovers the reason there was a puddle in the first place. The storm drain was backed up, causing water to overflow onto the floor. Digging deeper, the investigator asks, why was the storm drain never fixed even though it was clearly a problem? He discovers that the supervisor never filled out a maintenance request form, which would have alerted maintenance to the problem. Although the supervisor was aware of the water on the floor, the conclusion of the investigation showed he simply got busy with other things and forgot about it. Remember, root causes always pre-exist surface causes, and it's only by discovering the root cause and eliminating it that safety improvements are long-lasting. Unless the investigator conducts an effective analysis of the information, using a method that allows them to dig down to discover the root cause, coming up with solutions that will make significant safety improvements is all but impossible. One of the most popular methods is called 5 whys analysis. It's a straightforward approach to analysis that allows an investigator to determine the root cause of an accident without the need for complex statistical analysis. And that simplicity is one of its strengths. How does 5 whys analysis work? It begins by identifying a specific problem, then asking why the problem occurred. If the answer doesn't identify the root cause, then another why is asked, and the question keeps getting asked until the root cause is identified. This form of analysis is called 5 whys because, on average, it takes asking why 5 times before the root cause is found. But keep in mind, 5 is only an average. Depending on the accident, the root cause may be discovered in as little as 2 or 3 whys, or it could take asking why 6, 7, or more times before the root cause is found. The number of steps isn't important. What does matter is that the underlying cause of the hazard is identified so that it can be permanently eliminated. How do you know when you've identified the root cause? When continuing to ask why no longer yields useful information that can help prevent a recurrence. For example, an employee working at a banding station lifts sheets of metal from a side loader to a platform. As the employee bends to pick up another sheet, he hears a pop occur in his back, and suddenly, what had been a mild ache becomes excruciating pain. To prevent future incidents like this, the investigator keeps asking why until the true root cause is discovered. The first why the investigator asks, why did the employee hurt his back, results in the answer, the employee bent while lifting. The investigator continues to dig. Why did he bend? Because the metal sheets were near the floor. Why were the sheets near the floor? Because the employee left the side loader's forks on the ground, mistakenly thinking that this would be the safest work practice. Why did the employee think this? Because the sheets were going to be transferred to a platform that was also low to the ground. Why was the platform positioned so low? Because a setup that would be more ergonomically correct had simply never been identified and put into practice. When there are no more useful answers to the question why, then the root cause has been reached. In the final stage of an accident investigation, the investigator brings all that they've learned about the accident into a report that includes the evidence they've uncovered, their analysis of this information, and, most importantly, their recommendations for how to eliminate the causes of the accident. Obviously, the best corrective action is to eliminate the hazard altogether. When this isn't possible, hazard control measures are used to reduce risk to an acceptable level. Control measures are categorized and arranged in a hierarchy from most effective to least. Whenever possible, implementing engineering controls is the best choice, which includes such things as machine guards and exhaust fans. After this comes management controls, such as worker rotation and standard operating procedures. Work practice controls, such as good housekeeping and eliminating loose-fitting clothes. And at the bottom of the list, PPE. In order to be effective, the investigator's recommendations must get to the root causes of what happened and must suggest specific corrective actions rather than vague general guidelines. For example, instead of recommending that the facility install machine guards wherever required, it's more effective to write, "We should install machine guards on equipment X located at the southwest corner of Building 3. If we go back to the example at the banding station, the investigator went through a 5 whys analysis and determined that the employee had to bend when he lifted because the sheets of metal were too low to the ground. From here, the safety committee gathered to brainstorm a corrective action that would prevent this problem from happening again. Their solution? First, place the platform on a scale to help raise it to a better height ergonomically. And second, leave the side loader forks raised so that workers can simply pull the sheets off without bending. Oftentimes, the weakest part of an accident investigation is the follow-up after corrective actions have been put into place. The supervisor or other personnel responsible for the accident investigation should provide regular monitoring of the changes to make sure that they truly eliminate the hazard. For many people, the word accident conjures up images of a serious, even dangerous event that's impossible to anticipate and beyond our control to stop. Fortunately, in the workplace, this is rarely the case. By successfully learning from previous accidents and near misses, the accident investigator can anticipate future hazards and put in motion changes that help achieve a very important goal, a safer workplace for everyone.